Our third problem that we're going to work is y equals negative 3x squared plus 7. So we're going to go through the steps that we have written over here. The first one is, are we in y equals format? Yes, we are. Good, we're done with that. The second step is to find our axis of symmetry. So let's identify our a, which is negative 3, our b. Now, our b is not just whatever's right behind the x squared. It's whatever number is attached to an x. This is not attached to an x, so this is not our b. There's not an x in this function, so our b is actually 0, and our c is 7. Pay attention to that. That's a mistake that a lot of people will make. So we're going to find our axis of symmetry. X equals negative 1 times our b, which is 0, over 2 times our a, which is negative 3. So that becomes 0 over negative 6, which is 0. So our x value is 0. We're going to take that and we're going to plug it back into our original equation. So we're going to go back to here and we're going to say y equals negative 3 times 0 squared plus 7. And we can plug that into our calculator, but 0 squared is 0 and 0 times negative 3 is 0. So 0 plus 7 is y equals 7. So we've plugged it in and found our axis of symmetry, where we've plugged it into the original axis of symmetry formula, found the axis of symmetry, plugged it into the original function to find our y value. Now we can write down what our vertex is, which is our x, and our y values written as an ordered pair. And then we can identify our max and our min. Remember, we identify our maximum and our minimum by looking at the a value. And the a value in this case is a positive a, or is a negative a, because it's negative 3. And since it's a negative, we're going to have a maximum. And the value of that maximum is whatever our y is. Our domain, like all functions, all quadratic functions, is all real numbers, because we can plug any number in to that function and get a y value. Now our range, also kind of based off of our a value and our y that we've solved for. Our a value is negative, so we're going to say that y is less than or equal to, and we're going to take that y that we've solved for and we're going to plug that in to say that our range is y is less than or equal to 7. Let's work one more problem. And I want to just kind of go through the steps here. So our fourth example, is 5x plus y plus 6 equals 2x squared plus 5x. So, are there other set of notes here? This was page 2 of our notes. We're going to go through there. Is it in y equals format? No, it is not, so we need to do that. So I'm going to take and I'm going to move these two things, the 5x and the 6, to the other side to get y by itself. So I'm going to subtract 5x. I'm going to subtract it from this x value. So those two will cancel out. I'm going to subtract 6. There's no constant over here. There's no c value already over here, so I'm just going to put it on the end right there. So those cancel out, and I'm left with y equals, I don't have anything to combine with my 2x squared, so I bring it down. Positive 5x minus 5x, those cancel each other out. And negative 6 doesn't have anything to combine with, so I bring that down. So I've rewritten my function to say y equals 2x squared plus 6, or minus 6, so we've got it in y equals format. Next thing we want to do is we want to find our axis of symmetry. So let's identify our a, which is 2, our b, it canceled out. It's gone, so it's 0, and my c is negative 6. So I'm going to say x equals negative 1 times b, which was 0, times 2 times a. So we get 0 over 4, and that simplifies to 0. So there's my axis of symmetry. And then I'm going to plug that into my original function. So I'm going to say y equals 2 times 0 squared minus 6. And I can plug that into my calculator, or I can just do it real quick. Anything times 0 is 0. And I'm left with y equals negative 6. So I plugged in. Now I can write down what my vertex is. So my vertex is my x that I solved when I found the axis of symmetry, my y when I plugged that axis of symmetry in. And then I can determine if I have a maximum or a minimum. My a value is a positive number, and when I have an a value that is positive, that means I'm going to have a minimum because it's going to be in the bottom of the bowl. And that minimum value is -6. And then my domain is all real numbers. And my range, once again, because my a is positive, my range is going to be greater than or equal to. And I'm going to use that y value again, so it's going to be anything greater than or equal to -6.